Part A just wanted you to sketch the slope field at these 6 points. So usually when they ask you to sketch a slope field, they just have you sketch it at a certain number of points. Usually it's more than 6, although a couple of the ones I asked you to do were at 6 points. So for this, I mean, if there's only 6 points, it's easy enough to just plug in each point individually. But if we notice that anytime y is 0, this derivative should be 0. So those two should be zeros. And then we can plug in 0 for x, but y for 1, and then that should give us what? Should give us a slope of about -1. About like that. And then up here, we should be at y is 2, which gives us 4 over -1, so much steeper, -4. And then over here at 2, 1, we should have 1 over 1, so we should have a slope of 1. And here at 2, 2, we should have 4 over 1, so a slope of 4, pretty steep again. And that's what it should look like. And this was, for how easy it was, you would be surprised that that was worth 2 points. 1 for these two, and 1 for these 4. And very, very often, the breakdown for the slope field questions, if you get all of the slopes that are supposed to be 0, that's worth 1 point. And then all the rest of them are worth a second point. Any questions on that? All right. Part B. So part B says y equals f of x is a particular solution to our differential equation. We want to write an equation for the line tangent to y equals f of x. And so if we're going to write the equation of a tangent line, we need to have a slope and we need to have a point. The point is given to us. There's our point, 2, 3. But our slope we need to find. And so if we're writing the equation of the line tangent to f of x, where f of x is the solution to this differential equation, that tells us that the derivative of f of x is this. So to find the slope, that should be our derivative evaluated at the point 2, 3. And that looks like it is 9, right? 3 squared over 2 minus 1. So we would then write y minus 3 equals 9 times x minus 2 using point slope form. And that's worth 1 point for this tangent line. And then you're supposed to approximate it at 2.1. Well, that'd just be y minus 3 equals 9 times 2.1 minus 2. Or 0.1 times 9 is 0.9, plus the 3 would give us y equals 3.9. And that was also worth a point. So you got 4 points for parts A and B there. Any questions on B at all? Okay. And hopefully those both were pretty straightforward. Part C, as I think I mentioned yesterday, that the solving of the differential equation is usually more heavily weighted. It's worth 5 points out of the 9. And so we'll start with dy dx equals y squared over x minus 1. And I would say 99% of the time, the first step in any of these solving the differential equation problems is separating the variables, and it's always worth a point. So we'll divide by the y squared, and we'll multiply the dx to the other side. I should probably write the x minus 1 there still. So right there, 1 point already. That's supposed to be around the 1. 1 point for separating the variables properly. You get 2 points for this year's one if you were able to get both antiderivatives correct. So this is just the integral of y to the -2, which is -1 over y. This does not equal the natural log of the absolute value of y squared. This is a very common mistake, right? You see the thing in the denominator and you just make it natural log the absolute value of it. If you're going to do that, you have to only have a single variable down here. Okay? And then you have to do the u substitution to get that if you have a function. So I would have had to let u equal y squared and then find my du up here, which I don't have. So you just do y to the -2 and integrate that. So please be careful with that. This does not equal that. Oh, yeah, I didn't write my 1 over, did I? Sorry, 1 over x minus 1. I should probably write that. I don't know why I decided to move that x minus 1 into the numerator. Definitely 1 over x minus 1. All right, so 1 point here for this correct antiderivative. And then 1 point over here, if you do this one correctly, this one you do the u sub, you let u equal x minus 1, and then du is just dx. And really that, we'll put the dx up here, we'll make this look how it should actually look. So u equals x minus 1, du is dx, so this just becomes du over u, which becomes natural log absolute value of u plus your constant. So 1 point for getting natural log absolute value of x minus 1. And then you need to have the constant. If you don't put the plus c, you cannot get more than 3 points for this one. But then you also need to go through and you need to use your initial condition. And what was the initial condition there? Was it 2, 3? Or was it 3, 2? I don't remember.
It was 2,
2, 3.
2, 3? Okay, so we'll plug in 3 for y. And 2 for x. Natural log of 1 is 0, so that's just your constant is -1/3. And so from there, that's your 4th point, successfully plugging in your initial condition to get your constant. Then you go back up, -1 over y equals natural log absolute value x minus 1 minus 1/3. And if you don't feel like getting a common denominator here and you just want to write -y equals 1 over this, that's fine. I would prefer to get a common denominator, but it's up to you. And then you just get y equals negative of that. And that's your answer. And you do not need to put the interval in which it's valid. They make a note of it always on the scoring guidelines. But it's not necessary for you to put it unless they specifically tell you to. And so part C was 5 points. Any questions there on part C?
Wait, so if you did the common denominator, would the answer be 3 over 3 natural log of the absolute? Wait, what's the answer if you just did the common denominator?
So we have -1 over y equals natural log absolute value x minus 1 minus 1/3. So that gets you -1 over y equals 3 ln absolute value x minus 1 minus 1 all over 3. And then you'd have -y equals 3 over 3 ln absolute value x minus 1. And, throw the negative over there.
Awesome, thank you.
Yep, or you can also distribute the negative through and make it 1 minus 3 ln in the denominator. You could do the same thing here. Instead of just putting the negative out front, I believe in their scoring guide, they actually wrote it as positive 1/3 minus natural log absolute value of x minus 1. So, but you don't have to do that. You can leave the negative out in front. You can distribute it through. You can write it with the number in the numerator. It's up to you. All right. believe this is the next one I asked you to do. Does that look right?
Yep.
Perfect. So first thing is just doing the slope field. 6 points once again, so maybe just plug in each one of them, shouldn't be too difficult. 0, 1, so 0 for x, 1 for y, looks like that gives us -1. 0, 2 is going to give us -2, and 0, -1 is going to give us a +1. 1, 1 is going to give us +1, and 1, 2 is going to give us 0, and then 1, -1 is going to give us 3. And again, this was 2 points, 1 point for that one, and 1 point for all the rest of them. Good or no? All right, I'll assume that's a yes. So for B, find the second derivative. All right, well, the second derivative should be the derivative of the first derivative. Derivative of 2 with respect, or 2x with respect to x is 2. Derivative of -y with respect to x is minus dy dx. So we'd say 2 minus 2x minus y, or 2 minus 2x plus y. So that's 1 point for correctly getting the second derivative. And then it asks, well, determine the concavity of all solutions for the given differential equation in quadrant 2. Well, quadrant 2, right, in quadrant 2, x is less than 0, but y is greater than 0. And if x is less than 0 and y is greater than 0, that tells you that 2 minus 2x plus y is always greater than 0. And so if the second derivative is always positive, that will tell us that it is always concave up. Good or no? Any questions on part B? One point for actually saying concave up with a reasoning. Is there another way to do that, or is that the only way? As far as I can see, I don't offhand see another way to do it. Did you try to do that one a different way? Yeah, if you want to tell me what you did, I can let you know if that's what you did is right. But I don't offhand, I don't see another way. I haven't really thought, other than since you just asked much about it, because that's how I would have done it. Yeah, I don't think there is. So if you want to ask later also, you can show me your work. All right, part C. So we've got some function y equals f of x is the particular solution to our differential equation with the initial condition f of 2 equals 3. And we want to know, does f have a minimum, a maximum, or neither at x equals 2? Well, if it's going to have a minimum, if the function f has a minimum, maximum, or a maximum at x equals 2, what does that tell you about the derivative? It either has to be
0 or undefined.
Exactly. So we will take our derivative and evaluate it at x equals 2. which is y equals 3, which gives us what? Our derivative was 2x minus y. That'd be 4 minus 3, which is 1. And if the derivative is not 0 and the derivative is not undefined, then it has neither a min nor a max. Right? No critical value at 2, 3. And surprisingly, that was actually worth 2 points. 1 point for finding this and 1 point for explanation. Any questions there? Right, part D. So now part D is the part where normally you have to solve for the actual equation, but this is not what they're asking you to do for this one. And this one gets a little bit complicated. We got to use a little trick to solve this. We want to find the value of constants m and b so that y equals mx plus b is a solution to the differential equation. All right, so we got y equals mx plus b is a solution to dy dx equals 2y. Was it 2y minus x? Or no, it's 2x minus y, right? 2x minus y. So first off, the derivative of y equals mx plus b needs to be equal to this, right? Because this is the differential equation that goes with y equals mx plus b. So let's start off with what is the derivative of y equals mx plus b? What is y prime? Should just be m, right? And that is the slope of this line, and it should be equal to our derivative. So we should be able to say that m is equal to 2x minus y. So what we're going to do is we're going to take 2x minus y, 2x minus y. I'm going to replace the y with something here in just a second. 2x minus y is equal to m, and y is mx plus b. Do y'all agree? If m equals 2x minus y, I could replace the y with mx plus b and say 2x minus mx plus b equals m. And that's just like solving a system of equations. True? That's how we solve a system of equations. So if I bring this m over here and distribute this minus sign through here, I've got 2x minus mx minus b minus m equals 0. Or I have 2 minus m times x minus b minus m equals 0. And what are m and b? M and b are just constants that we're trying to find. X is a variable. So the number of x's on the left-hand side of this equation should equal the number of x's on the right-hand side of this equation, shouldn't they? If this is an equal sign, right, then that means both sides, the left and the right, have to equal each other. So the number of x's over here should equal the number of x's over on the right-hand side. Would you guys agree?
Yeah.
I mean, if I write this, 2x squared plus 3x minus 4 equals ax squared plus bx plus c, you should be able to tell me what's a equal to. This is unrelated.
2. Yeah.
A is 2. What's b? B ought to be 3. And what should c be? should be -4, right? So same concept here, except on the right-hand side, how many x's do I have?
Zero.
0. So 2 minus m x's needs to equal 0 x's over here. So m is 2. And also, this is all just a constant, right? The constant on the left, -b minus m, needs to equal the constant on the right. So m equals -b, or b equals -2. Good or no?
Wait, I have a question. If this is a linear equation, how is it possible to get a 2x in your derivative?
Well, let's take a look at it. We got y equals, what do we get? 2x minus 2, right? True. And we're saying that at the point, oh, was it the point 2,3 or the point 3,2? I can never remember. 2,3? No, yeah, it didn't even matter for this one, right? We didn't even have a point for part D. What's the derivative here? The derivative, y prime, equals 2. Yeah? Does that equal 2x minus y? Well, let's see. 2 equals 2x minus y. Yep. Good or no? Does that make sense?
Yeah.
Yeah. So for that one, the point breakdown was 1 point for this, 1 point for this, and 1 point for the actual values. So you probably could have got 2 points on that without having to do all that annoying solving stuff. That little trick here, where we break it down into how many x's are on the left and how many x's are on the right, what's the constant on the left, what's the constant on the right. That's something people normally learn in pre-cal. So, and maybe, I don't know if they teach it in AIM3, but at least in pre-cal, I used to teach it. It's a method that you use in something called partial fraction decomposition to help solve, just helps you solve a system of equations. All right. I believe this was the next one I asked you to do.
That looks right.
Oh, good. All right. So first thing we need to do is just sketch that solution curve. Hold on 1 second. All right, sorry about that. Okay. So we're going to sketch our solution curve going through 0, 1. So there's our point at 0, 1. Should follow that trajectory, and then it should sort of dip down and come back up. And that should be worth, I am guessing, I actually have this one pulled up. Yep, 1 point. Good or no? As an easy 1 point. All right. Part B, write an equation for the tangent to the solution in part A at 0, 1. So we need a point, there's our point, and we need a slope. So we need to evaluate dy dx at 0, 1, which should be 3 minus 1 times the cosine of 0, which gives you 2. So y minus, well, we might as well just write in the slope intercept, right? This is a y-intercept. So y equals 2x plus 1. And 1 point for the equation. And then your second point comes from approximating f of 0.2. So y equals 2 plus 1, 1.4. Pretty easy 3 points on that one, I think. Any questions on A or B?
How close does this does the slope field have to be? Like the line?
I mean, it's got to pretty much look like that. I mean, you know, if yours was a little shorter here or a little taller or something, it's probably fine. But I mean, you know, you couldn't have had like something like that. That wouldn't be close enough. But I don't know if you, I mean, if you want to show me, or you can send a picture of it sometime and I can let you know if I would have given you the point for it or not. Or you can show me right after class or something. All right, part C. Part C is now asking us if we can solve this differential equation, right? So find a particular solution with the initial condition that f of 0 equals 1. Only 3 parts from A and B, or 3 points from A and B, so 6 points from part C for this one. So first off, we're going to separate our variables, and that's worth 1 point. So dy over 3 minus y, that's x, equals cosine x dx. And if we separate them, divide by the 3 minus y, multiply by the dx, you end up with this. This is 1 point for separating the variables. You get 2 points if you can anti-differentiate them both properly. So sine x, that's easy. Don't forget the plus c. We'll talk about the plus c in a second. And then dy over 3 minus y, that's a u substitution. U equals 3 minus y. And then du is negative dy, so you got to put a negative inside and outside. And the inside one goes away to give you your du. And you end up with negative natural log absolute value of u of 3 minus y. And so for this one, they actually gave you a second point for that, a third point for that, and a fourth point for literally just putting plus c. That's it. So 4 points already. Pretty easy to get those 4 points, I hope. And then you got a fifth point if you correctly used your initial condition, which was 0, 1. To correctly solve for c, and that gives you negative ln2 equals c. And so that is 5 points. And then from there, you needed to go back through and solve for y to get the 6th point. So negative ln absolute value 3 minus y equals sine x minus ln2. So divide by the negative sign, natural log absolute value 3 minus y equals ln2 minus sine x. Put the signs on those. Then you're going to exponentiate to give yourself absolute value 3 minus y equals, and we'll remember that this is e to the ln2 times e to the negative sine x. And e to the ln2 is 2. So 2e to the negative sine x. Then as we clear off the absolute value, we have to put a plus or a minus in front of there. And so then using our initial condition of 0, 1, we can decide whether or not it needs to be the positive or the negative. Well, the left-hand side of this, if I plug in 1 for y, needs to be positive, right? This is 2 equals plus or minus 2e to the negative sine 0. Well, sine 0 is 0, opposite of 0 is still 0. E to 0 is 1. I get 2 equals positive or negative 2. Well, 2 equals positive 2, not negative 2. So we're going to choose the positive and write 3 minus y equals 2e to the negative sine x. And from there, you add the y and subtract the other. Y equals 3 minus 2e to the negative sine x, or you can subtract the 3 and then divide by the negative 1. And that's your final answer. And that's your 6th point for part C. Any questions on that?
Did you have to simplify the e to the natural log of 2 minus sine of x, or could you leave it like that?
I always recommend simplifying it. It states, I mean, in the scoring guidelines, it doesn't show that it shows it simplified, but it doesn't ever say anywhere that you have to simplify it. In all the student samples, though, I always see everybody always simplifies it. They've never shown one where like somebody didn't simplify it and got the points. I want to say that if you don't simplify it, you're fine. I don't think that they're going to penalize you for that. But at the same time, you really should simplify it. So I don't, that's one of the things I don't have a definitive answer on. And I won't have a definitive answer on until I end up being somebody that goes and grades the AP tests for them some year. So try to simplify it, unless you just horribly can't do that. It just doesn't make sense to you or something. Sorry, that's not the best answer for you, but everybody good there with that one now, though, in general? Any questions on that? All right, I think this is the last one I asked you guys to do. Is that right? Yeah, okay. So we got dy dx equals e to the y times 3x squared minus 6x. Part A, write an equation for the line tangent to f at 1, 0 and approximate it at 1.2. So for part A, we're just going to find the slope like we've been doing with all the other ones like this. You'll note that this is a very common question in these. So dy dx at 1, 0 is e to the 0 times 3 minus 6, which is 1 times negative 3 or negative 3. And we'll have y minus 0 equals negative 3 times x minus 1. So that is your equation, which is worth, let's see. I think getting the slope is worth 1, getting the equation was worth 1, and then approximating 1.2. To get negative 0.6 was worth a 3rd point for part A. Everybody good there with part A? Hopefully you're getting used to the tangent line approximation ones in these differential equations. All right, for part B, we're just going to solve the differential equation. So step 1 will be to separate the variables. We'll bring the e to the y to the other side. So 3x squared minus 6x, yeah, minus 6x dx. And then we will integrate both sides. Once again, this one is not natural log absolute value e to the y. You should really rewrite this as e to the negative y dy. And then that's a u sub, u equals negative y. Du is negative 1 dy, so you're going to put a negative inside and a negative outside, and you end up getting negative e to the negative y. And on this side, you got x cubed minus 3x squared plus your constant. So 1 point for separating the variables, 1 point for each antiderivative, 1 point for putting plus c. Then you need to use your initial condition, which was, what was our initial condition? 1, 0, I believe. To find our constant, negative e to the 0 is negative 1, equals negative 2 plus c, so our constant is 1. And that's a 5th point. And then your last point is finishing solving, so negative e to the negative y equals x cubed minus 3x squared plus 1. Divide by a negative. Take the natural log. And divide by negative 1. And once again, you don't need to put the domain, but if you want to, you could just say negative x cubed plus 3x squared minus 1 has to be greater than 0, and that's good enough there. And that's 6 points for part B. Any questions on that one? How are we feeling about these? We feel like we're getting the hang of them?
A little bit.
A little bit. Good, I guess. So we will do some more, well, I mean, there's plenty more of this type in your packet that I posted. So any of those you want to work through, you're welcome to, and I can help out and answer questions through Remind. But there's another type of differential equation for your response that I also want to talk about, which looks like this. No slope fields, none of that stuff, just a whole bunch of writing. And this one's about a potato. And so when we take the quiz either on Wednesday or Thursday, one of the questions will be like the slope field ones, and one of the questions will be similar to this. And we'll do a few of these to practice in the next couple of days. So I think we'll start with, I'm going to give you 15 minutes to work through this one, and then we will talk about it afterwards. And then I'll assign a few of these for you guys to do tonight that we'll talk about tomorrow. Sound good?
Sounds good.
All right. Whether it does or not, that's what we're going to do. So you got 15 minutes to work through this, and then we'll talk about it. Ready to go. We've got a potato. We're taking it out of a pot. It's left to cool, blah, blah, blah. We've got a couple things. One, that at the initial time at t equals 0, the potato's temperature is -1 degrees Celsius. And second, that the temperature is always greater than or equal to 27 degrees Celsius for all times greater than 0. Then they give us a differential equation. dH dt is -1/4 h minus 27. H is degrees Celsius, and h of 0, like we said before, is 91. So part A wants us to write an equation of the line tangent to the graph of h at t equals 0. Okay, great. So same thing we've been doing. We need to write an equation using a slope and a point. Well, our point will be the point 0, 91, right? Because that's what h of 0 is. And our slope should be the value of dh dt at the point 0, 91. Well, we don't need to plug t equals 0 in anywhere because that's not in our differential equation, but 91 needs to go in as h. And that 91 minus 27 is 64 divided by -4 should be -16. So we should end up with the equation y equals 91 minus 16t, or -16t plus 91, since that's a y-intercept. And then so we need to use that to approximate the temperature at t equals 3. So y of 3 will be 91 minus 16 times 3, 91 minus 48, which is 43 degrees Celsius. And there were 3 points with that one. One was for getting the slope. One was for getting the actual equation, and one for getting 43 degrees. Everybody good there with part A, or any questions on part A? All right, part B wants us to use a second derivative to determine if our answer is an under or an overestimate. So this requires a bit more work. We're going to have to find our second derivative, which should just be the derivative of, what do we have, -1/4 of h minus 27, I think. Is that what our original one was? Yeah. So the derivative with respect to t of this is just the constant stays out front. And then the derivative of h with respect to t is dh dt minus 0. Right, derivative of -27 is 0. So we got -1/4 dh dt, or -1/4 of -1/4 times h minus 27, right? That's our dh dt. So we get 1/16 h minus 27. And what do we know about the value of h? We know that h is always greater than 27. And so if h is always greater than 27, then the second derivative is always greater than 0, which tells us that this is always concave up. H is always concave up. And if we think about a function, we talked about this a little bit the other day, if we think about a function that's always concave up and we approximate its value using a tangent line, well, everywhere but at that exact point where they're tangent, the tangent line is less than, this tangent line is less than h. And so we would say that our estimate from the tangent line is an underestimate. And all of that was worth 1 point. Any questions there on part B?
Wait, so which part of that exactly gets you the reasoning point? Is it just like the entire thing, or like
Yeah.
a specific part?
Yep. I mean, basically saying that it's an underestimate because the function is concave up.
So like if I wrote it's an underestimate because the slope is always increasing, does that count?
The slope is always increasing. Yeah, that's fine. Slope is always increasing is the same as concave up. That's what, I mean, that's what concave up means, that the slope is always increasing. So that'd work too. Yep. Any other questions on that part? All right, part C then tells us All right, we got this alternate model for t less than 10. Now it's g, which satisfies this differential equation. dg dt is negative g minus 27 to the 2/3. And they say find g of t, and then use g of t to find g of 3. So dg dt equals negative g minus 27 to the 2/3. So in order to find g of t, we've got to get the g to the other side. So dg over g minus 27 to the 2/3 equals negative dt, negative 1 dt. And to integrate g minus 7 to the 2/3 in the denominator, that's g minus 7 to the negative 2/3. And a simple u sub makes that u to the negative 2/3. So that'll become up to 1/3, you'll divide by 1/3. So you'll end up with 3 times g minus 27 to the 1/3 equals negative t plus some constant. Everybody good with that? You integrate? And let's see, it was just to start off with 1 point for separating the variables, 1 point for correctly integrating both sides, total of 1 point. And then another point if you successfully used your constant of integration and your initial condition. So our initial condition was that g of 0 was 91. So 3 times 91 minus 27 to the 1/3 equals 0 plus c. 91 minus 27 is 64. Cube rooted is 4 times 3 is 12. So we're getting a constant of 12. That's a third point. And then we've got 3 times g minus 27 to the 1/3 equals negative t plus 12. And so if you got this, some equation, whether you solved it for g or not, they gave you a 4th point for this. And then you needed to solve it all the way down and find the approximation, not the approximation, but the value at 3 to get the 5th point. So we divide by the 3. G minus 27 to the 1/3 equals negative t plus 12 over 3. And then we would have to cube this to clear off the 1/3 power. So g minus 27 equals negative t plus 12 over 3 cubed. And g is 27 plus negative t plus 12 over 3 cubed. And g of 3 would then be 27 plus 9/3 cubed, or 3 cubed. 27 and 27 is 54. So in order to get the last point, you need to have both the appropriate equation for g and 54 degrees Celsius. Good or no? How'd you guys do on that one? 9 out of 9? Or ignoring me. Cool. That's fun too.